All right, so the next problem that we're going to work on is another problem that, once again, we have a rational number to get rid of. But you're going to notice this time around that the rational number we actually have is a decimal. So I have a little side note here on how to clear rational numbers when you have a decimal. Now remember, when you have a fraction, you need to make sure that you are multiplying by the least common denominator. Now a decimal is a little bit different than that. Some of you might be sitting there thinking, "Oh, I can find an easier way to do this." Remember, it's a strategy that we're working with. If you want, I will gladly show you all when I come back on Wednesday a really long way on how to solve everything with decimals and rational numbers. Personally, I wish I had known this method back when I was your guys' age. So, um, when clearing a rational number, when you have a decimal, you are going to be focusing on um, the place values, okay? And we want to clear out the particular place value a problem is. So what you are going to do is you're going to find what the largest place value is, and you are going to multiply by a power I just did by a power of 10. Okay, and here's what I mean by that. This right now is in the tenths place. Okay, to make this a whole number, to make it no longer a just rational number, but to get to a whole number, you're going to multiply it by 10 because it's in the tenths place. Same token, if you had, for example, I don't know, 0.05 or 0.04, sorry, to make this a whole number, you would multiply it by a power of 10, which would be 100. Multiplying it by 100 has the decimal move, and then it just becomes 4. Same thing if you have 0.038. Notice now you are in the thousandths place. So you would multiply by it 1,000, and then that is going to clear out the decimal and leave you with just 38 as the whole number. Okay. Now the same thing holds true for when you, just like we solved with our fractions, you have to perform it on both sides because it's a linear expression, so you have to make sure you maintain balance. Now, we have 32.5, which ends in the tenths place. So what we're going to do is we're going to have 32.5 minus 3x, and we're going to multiply it by 10. And we need to make sure that you do the exact same thing on the other side. And what this does is it helps us clear out our rational number. Okay? 10 times 32.5 is just going to be 325. By multiplying it by 10, you are essentially having our decimal place constantly move however many zeros you're working on. 10 times minus 3x gives us negative 30x. Okay? Equals 2x times 10 gives us 20x. Okay? Now, once again, once you have this, it's no different than what we have been working on yesterday and last Friday. So the first thing we're going to do is we're going to get our coefficients over to this side. So we have 325 minus 30x, which then now is going to be plus 30x because that's our inverse, equals 20x plus 30x. And remember, feel free to pause at any time. Our 30x's over here cancel, leave us with 325 equals, well, 20x plus 30x is going to be 50x. Now, once you get this part, you are simply going to divide both sides by 50. Okay, and notice now it gives us an improper fraction. Well, we're left with x. And if you divide 350 into 325, you're going to get 6 wholes out. 50 is our denominator. You're going to have 25 left over. You're going to notice we have 6 and 25 over 100, or that's 6.5, or 6.5. Okay. Now notice that one went a lot smoother than adding 3x, having 5x equals 32.5, and then having to mess around getting to this final answer.